everybody. I want to give you a few-minute video talking about Unit 7, Lesson 8. I want to start with Activity 1. There's a table that we're used to trying to organize our thoughts when we have a new rule. So I want to talk about the example that it gives you in that first line of the table on Activity 1. So it gives you 5 to the third power times 2 to the third power. What I want you to do is think about, look, what do they have in common? What do they have differently? So you might want to take a second to think about that. What we see here, we have different bases. So our big numbers, they're different. Our exponent numbers, they're the same. They're both powers of 3. Up to this point, we've seen something kind of reversed. We've seen problems where our bases are the same, but our exponents are different. So it's kind of flip-flopped. It's what do you do when you have different bases but the same exponents? Here we memorized a bunch of rules. Like in this problem, we would add up those exponents because you're multiplying the same power together. We can't just do that though when we have different bases. There's going to be something more to it that we're going to have to think about. So here we're going to expand it. So expand means we're going to make it much bigger. We're going to multiply out every single number to see what are we dealing with here. So first we have 5 to the third power. That means we have 3 5s. 5 times 5 times 5. So we're expanding this first exponent. Remember, the exponent tells you how many of the numbers there are. We have 3 5s being multiplied together. Similarly here for the 2 to the third power, we have 3 2s being multiplied together. So 2 to the third power, 5 to the third power. Same thing, just expanded. Here, what I hope you guys notice is that we have the same amount of numbers in each set of parentheses. We have 3 5s and we have 3 2s. Well, what if we kind of paired these up? So we can multiply in any order. It's not going to change our answer here if we start multiplying and moving things around because we're just multiplying across for everything. An example of this, 2 times 3 is the same thing as 3 times 2. Both answers are 6, no matter which way you move those numbers around. So I want to move some numbers around. I want to pair up my 5s and my 2s, so I'll put 1 5 with 1 2. It's going to be 5 times 2. I'm going to put that in parentheses. I'm going to take another 5 times another 2. I'm going to pair those two up, 5 times 2. And finally, these last two together, I'm going to take a 5 and another 2, 5 times 2. So I've just kind of rearranged everything that I expanded here, and I want to see what I've got. Well, we all know that 5 times 2 is just 10. So I've got 10 times 10 times 10. Well, if I wanted to write 10 times 10 times 10, I could have, I'm going to write it up here to save some space, 10 to the third power. I have 3 of them. I've got 3 10s being multiplied by itself, and that would be my final answer. I wouldn't have to multiply out each of these 5s and each of these 2s to get a huge number. Remember, the reason that we use exponents is so that we can work with large numbers much easier. So this is our easier way of doing it. Let's see one more example here. What if we have, and this is not on your activity handout, you'll be guided through some other questions. This is a different one I just made up. What if we have 8 squared times 4 squared? So we have, again, different bases but the same exponent. So I'm going to expand out what we've got. I have 2 8s and I've got 2 4s. 2 8s, 2 4s. Everything's being multiplied together. I've expanded it out. Now I can match them up together, rearrange how they're being multiplied to kind of simplify my answer. I've got 8 times 4, and I've got 8 times 4. Well, 8 times 4 is 32. 32 times 32. How many 32s do I have? I have 2 32s. So my answer is 32 to the second power. Most of your work will be a little bit more than this. I'll have higher exponents, so you have to expand more. But as you do more practice problems, I hope that you see you're really just taking your bases, you're multiplying them together, and then your exponent remains the same. Your exponent's not going to change. So the more you do that, the more I hope you see that pattern. Don't forget to check out the summary page at the end of that handout. That'll have another couple of examples sort of explaining you through those steps. There's also practice problems in the post about the work for today. So those are optional, but if you want some more practice doing this, feel free to do so. And that key will become live whenever the assignments do. Again, as always, don't hesitate to reach out if you have any other questions. Thanks.